How do you do, fellow primates? Previously we spoke of the first members of our order, the primates. Shrew-like in nature, these guys enjoyed immense success after the fall of the dinosaurs before their descendants took the reins. But while Purgatorius and the Plesiadapiforms would enjoy big mammal money in their heyday, specialization some 50 million years ago would rend their heirs in twain, resulting in the strepsirrhines and the haplorhines. And within these two suborders, we see the origin of lineages whose descendants still roam the canopies and the sidewalks today. I am pleased to introduce you to the diurnal Adapids and the nocturnal Omomyids. But before we go too much further into the strange world and lifestyles that these suborders occupied, we first must deal with the controversy. The world of primatology and human evolution is indeed rife with drama, intrigue, and of course, academic infighting. 3 ideas existed originally, one of which suggested that the Adapids and the Omomyids were branches that terminated in the lemurs and lorises on the Adapid side and in the anthropoid primates on the Omomyid side. This is what I was taught in 2016, and what we will hold to for today's purposes. But do understand, some still propose that we broke ancient bread with the Adapids instead, and others still point to a mysterious and as yet unknown group for our ancestors. To be clear, an Omomyid plucked from the dusky Eocene forests would very much resemble a tarsier, while the diurnal Adapids would appear more lemur-like. Given that we are more similar morphologically and genetically to the tarsiers, it makes intuitive sense that our closer cousins would be the Omomyids. First, let us meet the riveting Adapids, strepsirrhines of yore clamoring through the ancient forests and basking in the midday sun. Adapids were everywhere, enjoying a whole host of available arboreal niches across Europe, Africa, and Asia. They were diurnal, meaning they hung around while the sun was out, and grew to some pretty decent sizes with Leptodapis around 20 pounds. Adapids had larger body sizes than the Omomyids, and they used this slower metabolic rate to adopt some full-liverous strategies. Eating leaves was generally the rage with the Adapids, along with the occasional fruit. They had some absolutely radical morphologies that had convergently evolved to look something similar to what we see in the Old World primates. Canines were beginning to become prominent, with some species even exhibiting some sexual dimorphism, such as with Notharctus. This is somewhat novel given modern lemurs have quite low sexual dimorphism, and when it pops up, the females are the ones who tend to reap the dimorphic benefits, with female ringtails being larger and larger canines found in the brown mouse lemur females. Other more monomorphic species have their own unique traits. Darwinius massillae had originally been pegged as a haplorhine due to the characteristics its type specimen, Ida, possessed. She lacked a tooth comb as well as grooming claws, but a full trait analysis ended up placing Ida with the strepsirrhines. Her fossil is impeccably preserved, with her fur still clearly visible and her last meal identifiable. It was leaves. Surprise. Ida was found in a lake deposit known as the Messel Pit, which was rich in CO2 back in the day. It is thought that this lake would periodically belch up toxic gases, and that Ida was leisurely enjoying the lakeside before she fell unconscious from a nearby CO2 burst of fumes and slipped into the waters, where she drowned and sank into the sediment below. Still, Ida had mostly flattened nails on grasping hands. She had a post-orbital bar and a split lip, along with a brain case quite large for her body size. She still was indeed a strepsirrhine primate. One characteristic that differentiates the Adapids from the Omomyids is the eye socket size. The Adapids were diurnal, so their eye sockets didn't need to be very big. In fact, they were rather small, similar to what you see in a lemur. But the Omomyids had enormous eye sockets, representative of their nocturnal lifestyle. The Omomyids resembled tarsiers more than anything else, and were likely insectivorous as they meandered through the nighttime air. They certainly lacked many of the features the anthropoids would come to know. For one, their orbits weren't entirely closed, meaning the allospheноid and zygomatic bones of the skull weren't in contact. They had primitive dental formulas that varied by species, and the brain case still had some growing to do. However, being the first haplorhines, they lacked the split lip that characterizes most other mammals, including the strepsirrhines. It was also likely that an Omomoyid experienced the first break in the gulo gene, a break that we humans, and of course all subsequent haplorhines and anthropoid primates, still possess. The gulo gene contains the terminal instructions for the synthesis of ascorbic acid, and thus vitamin C. All primates after this break, which occurred via the molecular clock some 60 million years ago, must get their vitamin C from their diets. This break is in the same location in all haplorhine primates, and given how rare the gulo break is in mammals in general, serves as excellent evidence for common ancestry. In fact, out of all mammals, it is only seen in the haplorhine primates, guinea pigs, and some bats, and it is in novel locations for each lineage, never altering down the genetic line. Furthermore, only primates with the broken gulo gene share regulation of CAMP gene expression by vitamin D, which occurred after the loss of the gulo gene, meaning there is now a subsequent alteration that would have to occur independently in each primate species, both extinct and extant. That is, if you wanted to disprove universal common ancestry. After all, it's far more statistically likely, by a broad margin, that this is an inherited break from an ancestor, rather than a unique break that occurred in every single primate species, independently, in the same location. The gulo break gave organisms possessing it an increased ability to fatten up thanks to the impact that it had on fructose uptake. This means that it was favored by natural selection, particularly in times of scarcity when there maybe wasn't quite enough to go around. Finally, tarsiers are the most basal primate to have the gulo break, further supporting the idea of common ancestry and the break occurring in an Omomyoid ancestor. The Omomyids were beasts of the night, slinking through the branches on short limbs while they stalked their favorite arthropods. Necro Lemur, which sounds like a metal band name, had long fingers and toes, along with a tail for balancing. Imagine inhabiting an Eocene forest. Dusk approaches, and far above you in the trees, dozens of pairs of eyes blink open as the Necro Lemurs begin their evening hunt. Most of the Adapid and Omomyid lineages went extinct at the Eocene-Oligocene boundary, as the climate became cooler and drier. And so 34 million years ago, their morphologically adept descendants were able to flourish into a myriad of forms. This includes animals that were starting to look a lot like lorises, galagos, and lemurs, but also the emergence of the early anthropoid primates. These guys would show up in three groups: the oligopithecids, the parapithecids, and the proplyopithecids. We'll also check in on the strepsirides and see how our cousins are doing, and how they ended up all by themselves on Madagascar or in the far-flung reaches of modern Asia. Next time we'll start to see some relatives that are looking a bit more like traditional monkeys, and we'll see their radiation before delving into the late Oligocene and the rise of the planet of the apes. But one thing is for certain. Thanks to the loss of our split lip and our inability to produce our own vitamin C, we sit snugly with the rest of the haplorhines. And it's all thanks to the tendencies and the mutations experienced by the rogue stealth player, the Omomyids.